Imagine a deep medieval night when the world drowns in silence, broken only by the distant chiming of monastery bells and the whisper of night wind through narrow city streets. In one of the houses, hidden from prying eyes behind a heavy oak door, flickers a dim light. This is not the light of an ordinary candle, but a special flame burning above mysterious substances, casting an ethereal glow that illuminates the bent figure of a man in a long robe. The air here is thick and saturated, filled with aromas you would encounter nowhere else on Earth. The thin, metallic taste of mercury mingles with the barely perceptible sweetness of silver dust. The sharp scent of sulfur interweaves with the earthy spirit of charcoal, and above it all hovers something indefinable, the aroma of possibility itself, the scent of hope for a miracle about to occur. In this half-darkness, where reality borders on dream and science intertwines with magic, one of humanity's greatest traditions is born. Here, among bubbling retorts and glowing flasks, among ancient manuscripts and enigmatic symbols, begins a story that will change the world forever. The story of a search for truth hidden in the depths of matter. The story of people who dared to look behind the veil of the ordinary and see wonder in the simplest things. We embark on a journey through centuries and continents, following in the footsteps of those called alchemists. These people lived in different eras, spoke different languages, worshipped different gods, but all were united by one great dream: to understand nature's secret language, to learn to read the hidden writings of creation, to gain power over substance and time. Their laboratories were temples of knowledge. Their experiments were prayers addressed to the unknown forces of the universe. Allow yourself to immerse in this atmosphere of ancient wisdom. Feel the breath of centuries. Hear the whispers of those who first spoke the incantations of chemistry, who first saw how one substance transforms into another, how dead matter comes alive under the master's hands. Today we learn their story, the story of alchemy, which began as a search for ways to turn lead into gold and culminated in the creation of all modern science. The history of alchemy began in deep antiquity, when the first people learned to work metals and noticed amazing transformations of substances. in the smoky forges of ancient Egypt, where the hot desert air mixed with the heat of furnaces, craftsmen observed how copper, combining with tin, transformed into bronze, a metal of completely different nature. This process seemed like magic, and it is no wonder that it gave birth to belief in the possibility of other miraculous transformations. Ancient Egypt became the cradle of alchemy, not by chance. Here, in the shadow of magnificent pyramids, among whispers of sacred texts and the aroma of incense, priests preserved secret knowledge about the nature of things. They believed that everything in the world consists of primordial matter that can take various forms. In underground sanctuaries of temples, illuminated only by oil lamps, secrets of working with metals, glass, and dyes were passed down. Egyptian priests developed a complex system of symbols to denote various substances and processes. Gold they depicted as the sun, silver as the moon, Mercury as the winged staff of the god Hermes. These symbols did not merely designate chemical elements. They carried deep philosophical meaning, connecting earthly processes with celestial phenomena. In the stuffy chambers of temples, where the air was saturated with incense smoke, initiates studied these secret writings by torchlight. One of the central figures of alchemy's early period was the enigmatic Hermes Trismegistus, the thrice greatest. His name is shrouded in mystery, and it remains unclear whether he was a real historical figure or a collective image of ancient wisdom. According to legends, Hermes Trismegistus lived in ancient Egypt and possessed knowledge surpassing the understanding of mere mortals. He is credited with creating the famous Emerald Tablet, a brief text containing the basic principles of alchemy. The Emerald Tablet begins with words that echoed through thousands of alchemical laboratories across the centuries. That which is below is like that which is above, and that which is above is like that which is below. This principle, known as the law of correspondence or analogy, became the foundation of all alchemical philosophy. Alchemists believed that processes occurring in their retorts and flasks reflected cosmic processes, and the transformation of metals was connected to the movement of planets and stars. In the early centuries of our era, the center of alchemical knowledge moved to Alexandria. the greatest city of the Hellenistic world. Here, in the shadow of the famous library, among the noise of port cranes and the cry of seagulls, worked the first alchemists known to us by name. The city's air was permeated with aromas of spices from the distant east, resin from African forests, and salt from sea spray. In this cosmopolitan atmosphere, Greek philosophy merged with Egyptian secret knowledge, giving birth to a new form of alchemy. One of the most famous Alexandrian alchemists was Zosimos of Panopolis, who lived in the 3rd to 4th centuries. His laboratory was located in one of the city's quarters, where narrow streets were filled with smoke from numerous workshops. Zosimos was the first to systematically record alchemical procedures, and his treatises became true textbooks for future generations of seekers of the philosopher's stone. In his works, he described in detail how, in the laboratory's half-darkness, by the light of oil lamps, one should conduct distillation, sublimation, and other operations. In Zosimos's descriptions, we see what a typical alchemical laboratory of that time looked like. The main item was the athanor, a special furnace designed to maintain constant temperature for long periods. The sound of crackling coals and the hissing of heating liquids created a special atmosphere of mystery. Shelves were lined with clay vessels of various shapes and sizes, each intended for specific processes. Distillation held a special place in alchemical practice. Alchemists noticed that when heated, many liquids turn into vapor, which can then be condensed back into liquid. This process seemed to them an analogy of death and resurrection, dissolution and restoration. In the quiet of night hours, when the city fell asleep, alchemists continued their work, watching drop by drop as distillate collected in the receiving vessel. With the decline of the Roman Empire and the rise of Islam, the center of alchemical research moved to the Arab world. Here, in the scorching heat of desert cities, among the rustle of palm leaves and the sound of gurgling fountains, alchemy received new development. Arab scholars not only preserved Greek and Egyptian texts, but significantly advanced the practical side of alchemy. The greatest of Arab alchemists was Jabir ibn Hayyan, known in Europe as Glauber. He lived in the 8th century in Baghdad during the flowering of the Abbasid Caliphate. His laboratory was located in one of the city's quarters, where the air was filled with aromas of bizarre spices and smoke from numerous workshops. Jabir was the first to systematically study the properties of acids and alkalis, discovered methods for obtaining nitric and sulfuric acids, and learned to purify various metals. In Jabir's works, we find detailed descriptions of alchemical operations. He tells how in the pre-dawn quiet, when the air was still cool after a hot day, one should begin preparing certain preparations. The sound of dripping water from cooling devices, the rhythmic crackling of coals in the furnace, the light whistle of steam, all this created a special atmosphere in which new knowledge about the nature of substances was born. Jabir developed a theory according to which all metals consist of two principles, sulfur and mercury. Sulfur was responsible for combustibility and color, mercury for metallicity and fusibility. Different proportions of these principles determined the properties of specific metals. Gold, according to this theory, represented the ideal combination of sulfur and mercury, and the alchemist's task was to find a way to bring other metals to this perfect state. Arab alchemists significantly improved laboratory equipment. They invented the alembic, a special distillation apparatus that allowed obtaining purer distillates. In the half-darkness of laboratories, illuminated only by oil lamp flames, these glass instruments looked almost magical. Transparent flasks and retorts in which mysterious transformations slowly proceeded seemed like windows into another world where different laws operated. One of the greatest achievements of Arab alchemy was the discovery of alcohol distillation. In laboratories where the air was saturated with vapors of various substances, alchemists noticed that when distilling fermented grape juice, one could obtain a liquid with amazing properties. This aqua vitae, water of life, burned with bright flame and had the ability to dissolve many substances that would not dissolve in ordinary water. In the 9th to 10th centuries, another outstanding alchemist worked in the Arab world, Ar-Razi, known in Europe as Rhazes. His approach to alchemy was more practical and less mystical than his predecessors. In his laboratory in Baghdad, where glass instruments gleamed in the light of burning lamps, he conducted systematic experiments, carefully recording results. Ar-Razi was the first to classify chemical substances by their properties, dividing them into mineral, vegetable, and animal categories. Razi described in detail the processes of calcination, dissolution, distillation, coagulation, and sublimation. Each of these operations required special skill and patience. For example, sublimation, the transition of a substance from solid to gaseous state, bypassing liquid, was one of the most mysterious processes. In the silence of night, when the laboratory was illuminated only by the dim light of coals in the furnace, an alchemist could observe how solid substance disappears in one part of the apparatus and reappears as crystals in another. Arab alchemists also made significant contributions to pharmacy development. In their laboratories, where the air was permeated with aromas of medicinal herbs and chemical reagents, new pharmaceutical preparations were created. They learned to obtain various metal salts used for treating eye diseases, skin conditions, and other ailments. The sound of mortars grinding minerals and herbs, the tapping of drops in distillation apparatus, receiving vessels. All this was part of daily work creating medicines. In the 11th to 12th centuries, alchemical knowledge began penetrating Christian Europe. This occurred mainly through Spain, where Christians, Muslims, and Jews lived in relative harmony. In the libraries of Toledo and Cordoba, where dusty sunbeams illuminated rows of manuscripts in Arabic, Latin, and Hebrew, European scholars became acquainted with treasures of Eastern learning. One of the first European alchemists was Robert of Chester, who in the 12th century translated several Arabic alchemical treatises into Latin. Working in the quiet of a monastic library by candlelight, he carefully transferred Arabic formulas and recipes to parchment, adapting them for European readers. His translations became the first alchemical texts accessible to Western European scholars. A mysterious author known as Pseudo-Geber played a major role in spreading alchemy in Europe. Under this name, several influential alchemical treatises were written in the 13th to 14th centuries, long attributed to the Arab alchemist Jabir. In reality, these works were created by a European author, possibly a Franciscan monk, who combined Arab knowledge with Christian philosophy. In Pseudo-Geber's treatises, we find detailed descriptions of alchemical procedures conducted in monastic laboratories of medieval Europe. The author tells how at twilight, when daily concerns gave way to nightly vigils, a monk alchemist would light lamps in his cell laboratory. The air quickly filled with smoke from burning coals and vapors from heating liquids, creating an atmosphere of mystery and concentration. Medieval European alchemists worked under completely different conditions than their Eastern predecessors. The cold stone walls of monasteries and castles housing their laboratories poorly retained heat, and alchemists had to struggle not only with the whims of chemical reactions, but also with harsh climate. On winter evenings, when wind howled outside windows and glass covered with frost patterns, laboratory work required special courage and persistence. One of the most influential figures of medieval alchemy was Albert the Great, a Dominican monk, philosopher, and natural philosopher of the 13th century. In his laboratory in Cologne, where stone vaults reflected flickering candlelight, many important experiments were conducted. Albert the Great was the first in Europe to obtain pure arsenic, studied properties of cinnabar and other minerals, and described processes for making various alloys. Albert the Great was not only a practicing alchemist, but also a philosopher who tried to reconcile alchemical teachings with Christian doctrine. In his works, he argued that studying nature was a way to know divine creation, and alchemical transformations reflected processes embedded by the Creator in the nature of things. This philosophical interpretation of alchemy helped it gain recognition in the Christian world, despite suspicions of connections with magic and sorcery. Albert the Great's most famous student was Thomas Aquinas, who, although not actively engaged in alchemy, recognized the possibility of metal transformation as a natural process that could be accelerated by human art. This viewpoint became dominant in medieval scholasticism and provided alchemy with legitimacy in the eyes of church authorities. In the 13th century appeared another outstanding alchemist, Roger Bacon, a Franciscan monk whom contemporaries called the Wonderful Doctor. His laboratory in Oxford was equipped with the latest technology of the time. Here, among gleaming glass instruments and rows of bottles with reagents, Bacon conducted experiments that were centuries ahead of their time. He was the first in Europe to describe gunpowder manufacturing in detail, studied properties of optical lenses, and experimented with magnets. Roger Bacon was convinced that alchemy should be based on experience, not just book knowledge. In his laboratory, experiment was the primary method of cognition. Careful observations, precise measurements, multiple repetitions, all this became part of his methodology. In the quiet of Oxford nights, when rain drummed outside windows and coals crackled inside, ideas were born that anticipated modern experimental science. The 14th century brought to alchemy a new figure who determined its development for centuries. This was the enigmatic Raymond Lull, a Catalan philosopher and mystic credited with creating numerous alchemical treatises. Although modern researchers doubt the authorship of many of these works, Lull's name became a symbol of alchemical wisdom. In texts attributed to him, we find detailed descriptions of how alchemical operations were conducted in late medieval laboratories. According to these descriptions, an alchemist's work began with prayer and purification. In the half-darkness of a cell, illuminated only by a few candles, the alchemist donned clean clothes and turned to the Almighty with a request for help in comprehending nature's secrets. Only after this spiritual preparation could one proceed to work with matter. Every movement, every action had to be conscious and purposeful. Alchemical treatises attributed to Lull are full of poetic images and metaphors. The philosopher's stone is described as the red lion, king of metals, elixir of life. The process of its creation is compared to birth and death, marriage of opposites, journey of the soul through various states of being. This symbolic terminology was not merely literary decoration. It reflected the deep connection between alchemical operations and spiritual processes. In the 15th century, the center of alchemical research moved to German lands. Here, in numerous principalities and free cities, alchemy received support from secular rulers who hoped to replenish their treasuries with its help. In castle basements and city houses, new laboratories arose where searches for the philosopher's stone continued by torch and oil lamp light. One of the most famous German alchemists was Johann Isaac Holland, who lived in the 15th century. His laboratory in one of the Rhine cities was a true wonder of contemporary technology, a complex system of distillation apparatus, precise scales, various furnaces for maintaining different temperatures. All this allowed conducting experiments of unprecedented complexity. On winter evenings, when snow swirled outside windows and dozens of lamps burned inside, Holland's laboratory looked like a magical grotto. Holland left detailed descriptions of his experiments, in which we can feel the atmosphere of a late medieval alchemical laboratory. He tells how important it was to choose the right time to begin work. Many operations should be started at sunrise or midnight, when planetary influences were most favorable. The sound of bells marking hours was a signal to begin one or another stage of the process. In German lands, alchemy became closely intertwined with mining and metallurgy. In the mines of Saxony and Bohemia, where miners' lamps flickered in underground galleries, and air was saturated with dust and vapors. Practical alchemists studied ore properties and processing methods. Many discoveries made in mines and smelters found application in alchemical laboratories, and conversely, alchemical methods helped improve metallurgical processes. Monasteries played a special role in alchemy's development. In the quiet of monastic cells, where the only sounds were bird songs in gardens and distant bell tolling, monk. Alchemists continued traditions laid by their predecessors. Monastic laboratories were often located in basements, where constant temperature and humidity created optimal conditions for many chemical processes. Stone vaults, covered with soot from years of furnace operation, kept secrets of many generations of researchers. In the 16th century, alchemy experienced a period of flourishing and simultaneously began its transformation into modern chemistry. This period is associated with the name Paracelsus, a Swiss physician and alchemist who revolutionized both medicine and alchemical practice. Paracelsus's real name was Philippus Aureolus Theophrastus Bombastus von Hohenheim, but he chose a pseudonym meaning surpassing Celsus, the famous Roman physician. Paracelsus rejected many traditional alchemical concepts and created a new system based on three principles: sulfur, mercury, and salt. According to his theory, sulfur was responsible for combustibility, mercury for volatility, and salt for solidity and solubility. This triad of principles became the foundation of iatrochemistry, medical chemistry, which became the predecessor of modern pharmacology. Paracelsus's laboratory in Basel was completely unlike traditional alchemical workshops. Here reigned a spirit of practicality and experimentation. Instead of searching for the philosopher's stone, Paracelsus focused on creating medicinal preparations. In his laboratory, where air was saturated with aromas of medicinal herbs and chemical reagents, new treatment methods based on applying mineral preparations were born. Paracelsus was the first to systematically use chemical compounds in medicine. He applied mercury preparations for treating syphilis, antimony compounds as emetics, various metal salts for external application. His approach to alchemy was deeply practical. He did not strive to transform metals, but sought ways to use chemical knowledge to alleviate human suffering. In Paracelsus's laboratory, one could hear not only traditional sounds of alchemical work, crackling coals, hissing liquids, ringing glassware, but also groans of patients whom he treated with his preparations. The physician alchemist did not lock himself in an ivory tower, but directly applied his research results to help the suffering. This was the beginning of alchemy's transformation from an esoteric discipline into practical science. Paracelsus's followers, known as Paracelsians or iatrochemists, continued his work in the 17th century. Their laboratories resembled modern pharmaceutical workshops more than traditional alchemical layers. In clean, well-lit rooms where every instrument had its place and every preparation was precisely labeled, new types of medicines were created. One outstanding iatrochemist was Johann Rudolf Glauber, who lived in the 17th century. His laboratory in Amsterdam was a model of scientific organization. Order reigned here. Every operation was carefully planned and documented. Glauber discovered many new chemical compounds, including the famous Glauber's salt, sodium sulfate, still used in medicine today. In Glauber's works, we see how alchemy gradually freed itself from mystical layers and transformed into exact science. He described experimental conditions in detail, indicated precise reagent proportions, and recorded temperature and reaction times. In his laboratory, where rows of neatly labeled bottles stood and precise scales and measuring instruments lay on tables, foundations of modern analytical chemistry were born. The 17th century was also the time of great aristocratic alchemists who turned the search for the philosopher's stone into a fashionable pursuit of high society. Their laboratories were located in luxurious palaces and castles, where alchemical instruments neighbored artworks and experiments were conducted surrounded by exquisite furnishings. In these salons, where air was perfumed with expensive fragrances and incense, alchemy became part of secular culture. One of the most famous aristocratic alchemists was John Dee, English mathematician, astronomer, and advisor to Queen Elizabeth I. His laboratory at Mortlake Castle was a true center of learning, where outstanding minds of the time gathered. Here, among ancient folios and gleaming instruments by the light of numerous candles, not only chemical experiments were conducted, but also philosophical disputes about the nature of matter and spirit. John Dee's laboratory was divided into several parts. One housed chemical instruments and reagents. Another contained astronomical instruments for determining favorable moments for conducting operations. And a third held an extensive library of alchemical and philosophical treatises. The air here was saturated not only with chemical vapors, but also with an atmosphere of intellectual search and scientific creativity. In the 17th century, alchemy reached its zenith at the court of Emperor Rudolf II in Prague. This melancholic ruler transformed his court into a center of alchemical research, attracting scholars from all over Europe. In the dungeons of Prague Castle, in laboratories carved from rock, dozens of alchemists worked by torchlight, each hoping to be the first to discover the secret of metal transformation. The atmosphere of the imperial court was permeated with mystery and expectation of miracles. In the long stone corridors of the castle, where footstep echoes reflected from vaults and torch shadows danced on walls, one could meet learned men in long mantles hurrying to their laboratories with vials of unknown liquids. The air here was saturated with aromas of chemical reagents, smoke from numerous furnaces, and the thin scent of ancient manuscript parchment. Among alchemists working at Rudolph's court, a special place was occupied by Edward Kelly, an enigmatic figure who still causes disputes among historians. Kelly claimed to possess red powder capable of turning any metal into gold, and demonstrated this transformation before the emperor several times. In his laboratory, located in one of the castle towers, where narrow windows admitted only dim light, Kelly conducted his mysterious operations. Contemporaries described how in midnight hours, when the entire castle was plunged in sleep, strange greenish light streamed from Kelly's laboratory windows, and the air filled with incomprehensible aromas. Servants told of strange sounds coming from the tower, singing or incantations in an unknown language, mixed with hissing of heating liquids and crackling of burning coals. Kelly's works are surrounded by such a veil of mystery that it remains unclear whether he was a brilliant alchemist or skilled charlatan. Some researchers believe he truly possessed special methods of working with metals. Others consider him a fraud who used sleight of hand and prepared alloys to create illusions of transmutation. In any case, his figure became a symbol of the mystery and contradiction of alchemical tradition. In the same 17th century, one of history's greatest alchemists worked in Germany, Johann Joachim Becher. His approach to alchemy was systematic and scientific. In his laboratory in Mainz, where rows of glass instruments gleamed in oil lamp light, Becher conducted methodical investigations of combustion and calcination processes. He was the first to propose the existence of a special combustible principle, which his student Georg Stahl later named Phlogiston. Phlogiston theory became the last great alchemical concept that determined chemical science development for an entire century. According to this theory, all combustible substances contained a special substance, phlogiston, which was released during burning. Metals, in theory supporters' opinion, were compounds of phlogiston with earthy residues, and to obtain pure metal, one needed to saturate ore with phlogiston. In 18th-century laboratories where phlogiston theory reigned supreme, alchemists tried to isolate this mysterious principle in pure form. In workshop half-darkness, illuminated only by burner flames and candles, they conducted countless experiments with burning various substances, the sound of crackling wood, hissing of heating metals, thin whistle of released gases. This entire symphony of chemical transformations accompanied searches for elusive phlogiston. The 18th-century alchemical laboratory was completely unlike the medieval workshop. Here reigned a spirit of systematization and precision. Instruments were standardized, reagents purified and classified, procedures described in detail. In these laboratories, where every shelf was labeled and every experiment thoroughly documented, alchemy took its final steps toward becoming modern science. One of the last great alchemists was Johann Rudolf Glauber, whose laboratory in Amsterdam became a model for many followers. Here, in bright rooms with large windows where daylight was supplemented by numerous mirrors and lenses, a special atmosphere of scientific search was created. Glauber was not only a practicing alchemist, but also a talented inventor who created many new instruments and methods. In contemporary descriptions, Glauber's laboratory amazed with its organization. Glass instruments were arranged with mathematical precision. Each reagent had its place. Temperature regimes were strictly controlled using special thermometers. The air here lacked the chaotic mixture of odors characteristic of old alchemical workshops. Each process proceeded in an isolated system, and ventilation ensured atmospheric purity. Glauber left detailed records of his experiments, in which we can trace the gradual transition from alchemical to chemical terminology. Instead of vague metaphors about philosophical mercury and red lion, he used precise substance names and clear process descriptions. In his laboratory, where silence was disturbed only by rhythmic clock ticking and quiet bubbling of distillation apparatus, the language of modern chemistry was born. The 18th century became a time of great discoveries that forever changed concepts about chemical process nature. In 1774, French chemist Antoine Lavoisier conducted his famous experiment with mercury calcination in a closed vessel. In his Paris laboratory, where precise scales neighbored perfect gasometers, a mortal blow was dealt to phlogiston theory. Lavoisier showed that when metals burn, their weight does not decrease, as should happen with phlogiston release, but increases due to combination with oxygen from air. This experiment, conducted in an atmosphere of solemn silence, when the only sounds were clock ticking and pen scratching on paper, began modern chemistry, and finally dispelled alchemical illusions about element transformation. In Lavoisier's laboratory, air was clean and transparent. The great chemist first understood the importance of precise measurements and controlled experimental conditions. Here was no place for romantic disorder of old alchemical workshops. Every operation was planned in advance, every result carefully recorded, every conclusion verified by repeated experiments. This was chemistry of the New Age, precise, rational, based on laws rather than mystical concepts. Lavoisier's discoveries meant the end of alchemy as science, but not the end of its influence on human culture. Alchemical symbols and images continued living in literature, philosophy, psychology. Great Swiss psychologist Carl Gustav Jung saw in alchemical processes projections of internal psychic processes, symbolic descriptions of human spiritual development paths. According to Jung, alchemists, without understanding it themselves, described the individuation process, becoming a whole personality. The philosopher's stone in this interpretation became a symbol of achieving psychic maturity, and alchemical operations became metaphors for internal soul work. In the quiet of his Zurich office, where shelves were lined with ancient alchemical folios, Jung discovered new meanings in old texts. Modern science inherited from alchemy not only numerous practical methods and instruments, but also a special attitude toward nature as a book that can and should be read. Alchemists first understood that nature speaks in the language of experiment, that its secrets can be comprehended not through speculative reasoning, but through practical work. In their laboratories, where thought and action, theory and practice combined, the experimental method was born, the foundation of all modern science. Alchemical laboratories were places where many chemical elements and compounds were first discovered. Phosphorus, discovered by Hamburg alchemist Hennig Brand in the 17th century, amazed contemporaries with its property of glowing in darkness. In his laboratory, where the mysterious glow of the new element was the only light source, it seemed that ancient alchemical dreams of creating artificial light had finally come true. Brand obtained phosphorus from urine, and this fact perfectly illustrates a characteristic feature of alchemical methodology: readiness to experiment with the most unexpected materials. Alchemists did not disdain anything in their search for truth. They distilled, calcined, dissolved everything that came to hand, from precious metals to human waste products. This universality of approach allowed them to make numerous accidental but important discoveries. In alchemical texts, we find the first descriptions of many processes that today form the basis of chemical industry: distillation, crystallization, extraction, sublimation. All these methods were developed in alchemical laboratories. In the half-darkness of medieval workshops, where air was saturated with vapors and fumes, foundations of technologies without which modern civilization is unthinkable were laid. Alchemists also made enormous contributions to metallurgy development. Their searches for ways to purify and ennoble metals led to creating new alloys, improving smelting methods, and inventing new furnace types. In hot workshops, where heat from molten metal mixed with cool night air and hammer sparks struck myriads of lights, technologies that determined human civilization development were born. Alchemy played a special role in glass-making development. Alchemists required transparent vessels for observing reaction progress, and they constantly improved glass manufacturing methods. In their workshops, where molten glass glowed like liquid sun, and masters created complex forms using simple tools, many types of laboratory glassware were born that are still used in chemistry today. The alchemical tradition gave the world numerous new medicines. Searches for the elixir of life led to discovering many useful medical preparations in laboratories of alchemist physicians, where medicinal herb scents mixed with chemical reagent aromas, tinctures, ointments, and powders were created that alleviated patient suffering and prolonged human life. Paracelsus and his followers first began systematically applying mineral preparations in medicine. Their laboratories became prototypes of modern pharmaceutical productions. Here, in an atmosphere of concentrated work where every operation aimed to alleviate human suffering, alchemy found truly humanistic meaning. Alchemy's influence on human thought development extends far beyond natural sciences. Alchemical philosophy, with its idea of microcosm and macrocosm unity, correspondence between earthly and celestial processes, influenced scientific worldview formation. The concept that nature obeys unified laws, that laboratory processes reflect cosmic patterns, became one of modern science's foundations. Alchemists were first to understand the importance of symbolic language for describing complex processes. Their symbol system, where each element and operation had its designation, became the predecessor of modern chemical nomenclature. In library silence, where learned men bent over ancient manuscripts trying to decipher alchemical symbols, the language of science was formed. Alchemy's aesthetic influence is also difficult to overestimate. Alchemical images and symbols inspired artists, poets, musicians for centuries. In paintings depicting alchemists in their laboratories, we see not only documentary evidence about the past, but also artistic comprehension of human striving for knowledge and world transformation. Literature also owes much to alchemical tradition. From Goethe's Faust to modern science fiction, alchemical motifs serve as symbols of human daring, striving to penetrate nature's secrets, master forces exceeding ordinary human capabilities. In these works, the alchemist appears as an archetypal figure of the scientist dreamer, ready to risk everything for knowledge. Modern psychology discovered in alchemy the richest source of symbols for describing human internal development processes. Alchemical operations are interpreted as metaphors for psychic processes, dissolution as overcoming old attitudes, distillation as consciousness purification, coagulation as new personality structure formation. In psychotherapist offices, where special atmospheres of trust and understanding are created, ancient alchemical symbols find new life. Philosophy also continues drawing inspiration from alchemical tradition. The idea of transmutation, transformation of one essence into another, became central to many philosophical systems. In philosophical office silence, where thought strives to penetrate being's deepest depths, alchemical concepts serve as models for understanding change and development processes. Even modern physics, with its concepts of element transformation in nuclear reactions, has in a certain sense realized ancient alchemical dreams. In nuclear physicist laboratories, where particles accelerate to incredible speeds and elements truly transform into each other, predictions that once seemed fantastic come true. Modern nanotechnology also has points of contact with alchemical tradition. The ability to manipulate individual atoms, create new materials with predetermined properties, transform some substances into others at the molecular level. All this resembles ancient alchemical dreams of complete matter control. In biotechnology, the transmutation idea found new embodiment in the possibility of changing living organism genetic codes. Modern biotechnologists, working in sterile laboratories where centrifuges hum and complex instrument indicators blink, in a certain sense, continue the work of ancient alchemists who strove to create artificial life. Computer technologies also carry echoes of the alchemical dream of creating artificial intelligence. In data centers, where thousands of processors continuously process information, and artificial intelligence solves increasingly complex problems. The ancient idea of creating thinking beings from inorganic matter is embodied. The ecological movement finds in alchemical tradition ideas about nature unity, all-world process interconnection, the necessity of harmonious human interaction with environment. In modern laboratories where environmentally clean technologies are developed, researchers are guided by principles that would be understandable to medieval alchemists. Future medicine also develops in directions anticipated by alchemical tradition. The idea of radical life extension, organism rejuvenation, treating previously incurable diseases using new technologies, finds embodiment in modern stem cell research, gene therapy, nanomedicine. Quantum physics, with its concepts of observer and observed phenomenon, interconnection, consciousness influence on material processes, returns us to alchemical concepts of spirit and matter unity. In quantum physicist laboratories, where reality obeys seemingly mystical laws, ancient intuitions about deep connections between consciousness and physical world resurrect. Modern cosmology, with its theories of element origin in star cores, cyclical matter, transformations in the universe, continues the alchemical tradition of searching for unified principles governing all nature transformations. In observatories, where telescopes penetrate cosmic depths, astronomers study processes that alchemists called nature's great work. Artificial intelligence and robotics embody the alchemical dream of creating artificial beings possessing reason and independent action capability. In laboratories where increasingly perfect robots are created, researchers face the same philosophical questions that troubled alchemists. What is life, consciousness, soul? Modern chemistry, grown from alchemy, continues developing in directions that would be understandable to ancient masters, creating new materials with predetermined properties, synthesizing complex organic molecules, developing catalysts that accelerate chemical reactions. All this continues the work begun by alchemists in their laboratories. In modern chemical laboratories, where robot automata conduct thousands of reactions daily, and computers model molecular processes, the spirit of experimental search that characterized alchemical tradition is preserved. Here, in an atmosphere of intense intellectual work, the great work of matter-nature cognition continues. The pharmaceutical industry directly continues the tradition of alchemist physicians who strove to create universal medicines. In modern pharmaceutical laboratories, where thousands of new compounds are synthesized, their biological properties tested, new drug delivery methods to organisms developed. The ancient dream of health elixir is embodied. Materials science develops toward creating smart materials capable of changing properties depending on external conditions. These developments resemble alchemical concepts of living matter capable of transformation and adaptation. In laboratories where self-healing coatings, shape memory materials, adaptive structures are created, ancient alchemical intuitions are embodied. Modern energy also connects with alchemical tradition, searches for new energy sources, developing more efficient storage and conversion methods, continue alchemical research on extracting subtle energies from matter. In laboratories, working with solar batteries, fuel cells, thermoelectric converters, researchers strive for the same goal as ancient alchemists: extract maximum energy from minimum matter. Nanotechnology represents the most direct continuation of alchemical tradition. The ability to manipulate individual atoms, create structures with atomic precision, program material properties at molecular level. All this embodies ancient alchemical dreams of complete matter control. In nanotechnological laboratory clean rooms, where every dust particle is controlled and processes occur on scales invisible to human eyes, medieval alchemists' boldest fantasies are realized. Biotechnology and genetic engineering continue alchemical tradition in living nature. The ability to change genetic code, create new life forms, program living organism properties, embodies alchemical concepts of biological sphere transmutation possibility. In laboratories, where microorganisms are used as drug production factories, where plants are modified to increase yield, where aging and regeneration mechanisms are studied, the search for life elixir continues. Modern psychology and psychotherapy also develop in directions anticipated by alchemical tradition. The idea of personality, internal transformation possibility, transforming base, instinct, lead into higher spiritual quality, gold, underlies many psychotherapeutic methods. In psychologist offices, where special atmospheres of understanding and acceptance are created, internal alchemy processes occur. Information technologies also carry elements of alchemical philosophy. The concept that information can transform reality, that virtual processes can influence the material world, that consciousness and matter are connected by deep links, finds embodiment in computer technology, development, artificial intelligence, virtual reality. Modern elementary particle physics, in its search for matter, organization, fundamental principles, continues the alchemical tradition of seeking everything's foundation. In particle accelerators, where matter accelerates to speeds close to light speed, where conditions existing in first moments after Big Bang are created, physicists investigate the same questions that troubled alchemists. What is matter made of? What are its transformation laws? Is there a unified basis for all nature diversity? Space technologies also develop in the spirit of alchemical tradition. The idea of planet transformation, terraforming, creating artificial biospheres, extracting resources from space objects, continues alchemical concepts of surrounding world transformation possibility. In laboratories, where space exploration technologies are developed, researchers strive for the same goal as alchemists: transform hostile environment into favorable for humans. Modern ecology, in its search for ways to restore damaged ecosystems, clean polluted environment, create closed industrial cycles, also continues alchemical tradition. The concept that humans can and should be nature's co-creators, that technology should work in harmony with natural processes, goes back to alchemical concepts of human and nature unity. In modern scientific laboratories, where research is conducted in science's most advanced directions, the same atmosphere of creative search that characterized alchemical workshops is preserved. Here, among the most complex instruments and computer systems, in an atmosphere of intense intellectual work, the great work of world cognition and transformation begun in medieval alchemist laboratories continues. Modern researchers, like their alchemist predecessors, are driven by the same fundamental questions. What is matter? How is it structured? What are its transformation laws? Can these transformations be controlled? What is consciousness's role in material processes? These eternal questions, posed in antiquity, continue inspiring human reason to new discoveries and achievements. Thus, alchemy, beginning as an attempt to turn ordinary metals into gold, developed into a mighty tradition that gave humanity not only numerous practical discoveries, but also a new way of thinking about nature, new research methods, new concepts about human reason possibilities. In our days, when science has reached incredible heights, we can appreciate the true significance of alchemical heritage. It laid foundations of that scientific approach to the world that determines modern civilization development. And perhaps, in this quiet evening stillness, when daily bustle yields to nightly peace, it is worth remembering those nameless truth-seekers who, in their laboratory half-darkness, by flickering candlelight and molten metal gleams, laid foundations of our world understanding. Their dreams of metal transformation may have been naive, but their striving for knowledge, their readiness to dedicate life to truth-seeking, their faith that human reason can penetrate nature's secrets, remain eternal sources of inspiration. In the modern world, where scientific discoveries follow each other with dizzying speed, where technologies change our lives practically daily, it is easy to forget those modest beginnings from which all this might of human knowledge grew. But it was in those distant times when an alchemist bent over his retort, hoping to see transformation miracles, that foundations of that attitude toward the world we call scientific were laid. Alchemists believed that nature speaks with humans in the language of symbols and transformations, that each substance, each process carries deep meaning, that the material world reflects spiritual truths. This faith in nature's meaningfulness, in its cognition possibility, in hidden connections between various phenomena existence, became the foundation of scientific worldview. In alchemist laboratories, the importance of precise observation, careful experiment, systematic natural process study was first realized. Here, among smoke and vapors, among glass vessel ringing and coal crackling, that approach to cognition was born that subsequently led to human reason's greatest discoveries. Alchemical tradition taught humanity to see in matter not dead substance, but living, dynamic reality, capable of infinite transformations. This view of matter as something fluid, changeable, full of hidden possibilities, proved prophetic. Modern physics showed that matter truly represents energy concentrations capable of most unexpected transformations. Alchemists first understood that nature cognition requires not only observation, but also active intervention. Experiment. They were not content with contemplating natural processes, but strove to reproduce them in their laboratories. Change. Improve. This active approach to cognition became a characteristic feature of European science and largely determined its successes. In alchemical workshops, the importance of precise measurements, experimental condition control, result reproducibility was first realized. Alchemists understood that obtaining reliable results required carefully observing all process conditions, temperature, time, substance proportions, operation sequence. This methodological rigor became the foundation of modern experimental method. Alchemical philosophy, with its concepts of world unity, correspondence between different reality levels, general nature law, cognition possibility, laid foundations of scientific worldview. The idea that behind visible natural phenomenon, diversity hide simple and universal principles became science's guiding star. Alchemists were first to attempt creating universal language for describing natural processes. Their symbol system, despite complexity and sometimes confusion, represented an attempt to find precise designations for chemical substances and operations. Modern chemical nomenclature grew from these early attempts to create scientific language. In alchemical laboratories, the importance of substance purity for obtaining reproducible results was first realized. Alchemists developed numerous purification methods: distillation, crystallization, sublimation, extraction. These methods still form the basis of preparative chemistry. Alchemical tradition educated a special personality type: researcher ready to dedicate life to truth-seeking, capable of patient and meticulous work, not afraid of failures, and ready to start over. This type of scientist ascetic became the idol of scientific community. Alchemists first understood the importance of interdisciplinary approach to cognition. In their works, chemistry and physics, medicine and philosophy, astronomy, and psychology were combined. This synthetic approach to knowledge proved very fruitful, and today experiences new revival in interdisciplinary research form. In alchemical workshops, the importance of technical progress for science development was first realized. Alchemists constantly improved their instruments, invented new methods, developed more efficient procedures. This connection between science and technology became a characteristic feature of modern civilization. Alchemical philosophy laid foundations of modern evolution and development concepts. The idea that everything in nature is in constant motion and change, that lower forms can transform into higher ones, that development goes from simple to complex, anticipated many modern scientific concepts. Alchemists were the first ecologists in the sense that they understood nature-process interconnection, cosmic factor influence on earthly phenomena, necessity of harmonious human interaction with surrounding world. These ideas today acquire special relevance in connection with modern ecological problems. In alchemical texts, we find first attempts at quantitative natural process description. Alchemists understood the importance of precise proportions, temperature, and time measurement, accounting for all factors influencing reaction progress. This striving for precision and quantification became the foundation of modern exact science. Alchemical tradition educated respect for nature as human teacher. Alchemists believed that nature itself shows humans improvement paths, that one needs only to observe carefully and correctly interpret its lessons. This approach to nature as knowledge source remains relevant today. In alchemical laboratories, the importance of international scientist cooperation was first realized. Alchemical knowledge was transmitted from country to country, translated from language to language, enriched by different culture experience. This tradition of international scientific cooperation became the foundation of modern science. Alchemists first understood the importance of education and knowledge transmission to next generations. They created schools, wrote textbooks, developed teaching methods. Many scientific pedagogy principles go back to alchemical tradition. In alchemical workshops, scientist social responsibility was first realized. Alchemists understood that their discoveries could be used both for good and harm to humanity, and strove to direct their efforts toward serving people. This ethical component of scientific activity remains relevant today. Alchemical philosophy laid foundations of modern creativity, understanding as new creation process. The concept that humans can be nature's co-creators, that they can create what does not exist naturally, became the foundation of innovative activity. In alchemical texts, we find first attempts at systematic approach to nature study. Alchemists strove to create a holistic world picture where all elements are interconnected and interdependent. This systematic approach today becomes increasingly important for solving complex scientific and technical problems. Alchemical tradition taught humanity to value not only result, but also cognition process. For alchemists, the very path of truth-seeking was no less important than its ultimate goal. This philosophy of process, not just result, enriched human culture and remains relevant for modern science. In alchemical workshops, the importance of intuition and inspiration in scientific cognition was first realized. Alchemists understood that rational analysis should be supplemented by creative insight, that great discoveries often come not as logical reasoning results, but as sudden revelations. This intuition role in science is recognized by modern researchers. Alchemical philosophy laid foundations of modern beauty, understanding as truth criterion. Alchemists believed that true knowledge should be not only useful, but also beautiful. That beauty and truth are inseparably connected. This aesthetic component of science today plays an important role in scientific creativity. In alchemical laboratories, the importance of motivation and passion in scientific activity was first realized. Alchemists understood that achieving great goals requires not only knowledge and skill, but also burning love for truth, readiness to overcome any obstacles. This passion for cognition remains science's driving force. Alchemical tradition taught humanity patience and persistence in achieving set goals. Alchemists understood that great discoveries require time, that the path to truth can be long and difficult. But this should not stop the seeker. This philosophy of long-term efforts is important for modern science, where many projects require decades of work. In alchemical workshops, the importance of imagination and fantasy in scientific creativity was first realized. Alchemists understood that creating new requires first imagining it, that fantasy is a bridge between existing and possible. This imagination role in science today has received scientific substantiation. Alchemical philosophy laid foundations of modern development, understanding as spiral process, where each new turn repeats previous ones at higher level. The idea that progress goes not in straight line, but spiral, where old returns in new quality proved very fruitful for understanding science and society development. In alchemical texts, we find first attempts at creating universal theory, uniting all knowledge areas. Alchemists strove to find unified principles underlying all natural phenomena. This dream of all science unification remains one of modern science's main goals. Alchemical tradition taught humanity to see multi-level meaning structure in each phenomenon. Alchemists understood that the same phenomenon can be interpreted at physical, chemical, biological, psychological, spiritual levels. This multi-level interpretation approach remains relevant for modern science. In alchemical laboratories, the importance of symbolic thinking for scientific creativity was first realized. Alchemists understood that some truths can be expressed only through symbols and metaphors. That figurative thinking complements logical. This symbol role in science today is studied by cognitive psychologists. Alchemical philosophy laid foundations of modern theory and practice unity understanding. Alchemists did not separate knowledge and action, theory, and experiment. For them, these were inseparably connected aspects of unified cognition process. This theory and practice integration remains modern science's ideal. Thus, alchemical tradition left humanity priceless heritage, not only concrete discoveries and inventions, but also special thinking method, special world attitude, special cognition philosophy. This heritage continues living and developing in modern science, inspiring new researcher generations to truth-seeking. And when we fall asleep in modern night quiet, illuminated by electric city lights, warmed by heat created by modern technologies, protected from diseases by medicines synthesized in modern laboratories, it is worth remembering those distant ancestors who, in their workshop half-darkness, by flickering candlelight, laid foundations of all these wonders. Their dreams of metal transformation did not come true in the form they imagined, but were realized in much more grandiose form, as human reason transformation from blind force into mighty instrument of world cognition and transformation. Let their memory be for us a source of inspiration in our own truth, beauty, and perfection searches. Let their faith in human possibilities strengthen our determination in overcoming difficulties. Let their devotion to science remind us that cognition is not only profession, but also calling, not only work, but also service to humanity's highest ideals. In this evening quiet, when day transitions to night and consciousness prepares to plunge into sleep, alchemical wisdom continues its work in our reason depths, connecting conscious and unconscious, rational and intuitive, known and unknown into unified creative search stream that will never cease while human spirit lives.